Am I? Never had a guy tell me that before. Is that the time? I heard a good cell phone ring. Very cool. So good afternoon. I think it's afternoon now, or close enough to it. Welcome back to GrrCON 2019. So in this session, Adam Ringwood is going to be talking about Varna, which he explained to me very shortly is a Swedish name for alarm. So do not be alarmed. He's going to tell you some really good stuff. So Adam.
Hi, how's it going? So I'm going to talk about Varna, and this mic has a very short distance, so I'm going to have to kind of eat it. But Varna is a tool for monitoring AWS. So we're just kind of going to get started, and I'll explain what's going on. First off, I'd like to preface this with I'm going to make a mistake probably multiple times throughout this talk. I work with AWS all day, every day, and my brain has just gone scrambled due to acronyms and very similar names. And I'm going to call CloudTrail, which is the service that Varna works with, CloudWatch, because I also work with that on a day-to-day basis. So please forgive me in advance when I do this just horribly, and know that I mean CloudTrail and when I'm saying this. So this talk is for small shops. I think to kind of start off, it's really hard to do AWS security really well as a small shop, right? It's much easier if you have a team of 8 people whose whole job it is to configure your IAM policies and all of your security groups and everything like that. This talk is distinctly not for those people. This talk is for people who are a single person or maybe a small team of 1 or 2 that they're running an AWS account and they don't feel like they have any visibility or monitoring over it. It is also hopefully an inspiration to people to build and distribute smaller security tools. I think a lot of tooling around this industry is very large and requires 50 pages of documentation to read through. No one really likes doing that, right? No one likes getting up on a 9 a.m. and being like, I'm going to read docs till noon to figure out how something works. Not fun. This tool is designed to be immensely practical to you 5 minutes after you walk out these doors and read the setup guide and get it running. There shouldn't be any complicated things about it. If there is, that's a bug. You should contact me. As I mentioned, this talk is not for people who run really big security teams. You probably have better tooling available for you that you paid a lot of money for. You should probably use that. It does not solve all your problems. It will not solve all of your problems, or probably any of your problems, in a protective way in some sense, which is that if you need this tool, it is because someone has broken into your account and bad things are happening to you, and it will not save you. If you want to talk about protections, which I think is really important, and I think it's kind of a bad move on my part to release a tool that only does monitoring without any protections. But unfortunately, protections in AWS, due to how user accounts work and how you can get authentication in and out of AWS accounts, is very difficult. If you want to talk to me about this, I'm happy to chat with you afterwards. I will literally talk your ear about this topic for hours at a time. So as you mentioned, my name is Adam. I'm a security R&D engineer. I've worked with Endgame for a bit, and now I'm working at Elastic because Elastic bought Endgame. My day job is I work with a bunch of malware and a bunch of big data and that sort of thing, and that's actually how this tool kind of grew. It is a tool that we use internally to secure some of our accounts, and that's why we're here. This is my Twitter. If you have angry feedback or nice feedback, but typically it seems to be mostly angry, you can tweet at me and send me spicy memes, and I will appreciate it. So really quick, let's start off with just a high-level overview of what CloudTrail is really quick, because it will help people understand what this tool does. So CloudTrail is this tool that Amazon basically made to instrument their kind of control plane. And the way of saying this in a different way is every time you spin up an EC2 instance, every time you spin up a new user, every time you modify a bucket policy or something like that, Amazon actually makes an event in CloudTrail and has a full history of that and when that happens. And this is really nice. The sole problem with this is that CloudTrail was never designed to be interacted with as a mere mortal. It is very much designed around the fact that you have some scripts or something that you use to interact with it. Its interface consists of 2 things. A set of log files that get dumped into an S3 bucket, which we'll cover in a second, and then a very limited 90-day search window that you can also pull up. And this search window is fabulously limited and doesn't let you query for most things you want. So in this is what an S3 bucket with a bunch of CloudTrail logs looks like. So if you want to monitor your CloudTrail normally, and you're just like, I wonder what happened on Tuesday at 10 a.m. The normal course of action, if you actually need to look through the full ones, is you have to go to this bucket, navigate through a bunch of folders because there's an extensive folder hierarchy, go find the sections you need, grab them all, uncompress them, concat them all together, and then sort them by time, and now you're ready to go. I have yet to meet someone who has done this in less than 10 minutes. If you have, you're amazing. It's horribly unusable for most humans. It's pretty convenient for bots, which is why I wrote a bot to talk to it, but it is not the most intuitive, straightforward setup. So what does an event look like? Oh, that got cropped. So this is kind of what an event looks like. It's just a bunch of messy data that basically gets posted like this. And we'll talk a little bit why this is complicated. But first off, let's really quickly talk about what's in every event, just so you can see. Every event has these fields in it. And they're pretty straightforward. It's the region you're running stuff in. It's a global GUID that gets generated. It's the type of event. So in this case, it's an assume role. It's from where it's from. There's the event type, which there's a fabulous document that you should read because I don't understand it still, and it may be understandable to you. And then there's account ID, which is pretty important. And then there's source IP and there's user agent. There's actually one kind of cool note about source IP and user agent. So if you've spent a bunch of time looking at CloudTrail logs, you'll notice that pretty frequently Amazon, like right here, has put in their IP address and their user agent as their URL for their internal services. When you interact with the console, the web console in AWS, and you actually what'll happen is that it'll include your IP and your user agent. So if you make a user from the console, instead of actually getting the web console servers in this spot, it'll actually proxy through the user's IP and the user's user agent. This is tremendously useful and allows you to do some interesting geo-IP stuff that you normally wouldn't be able to do in a bunch of stuff like this. Now here's the complicated part. This is what I like to call the wildcard fields. So these three things are defined basically in spec, and then there's no other structure to them. So every time you get an event, it appears to me roughly that you can define this yourself. So some people will put a bunch of request parameters in there that might be useful. Some people will put a bunch of response elements in there. For instance, if you're logging in through the console login event tells you whether that login succeeded or not. This is pretty useful. As far as I can tell, these are vaguely documented or documented exactly nowhere. So if you want to write rules, you have to basically cause the event to happen that you're looking for, and then actually look through the metadata of these elements to find the structure of them to write rules. I really wish this was not the case, and I'm sorry to tell you it is, because it is horrible as a user experience. And then there's the user identity field. Amazon has about 5 or 6 different ways to be authenticated to an AWS account, all of which are fairly complicated and come with some interesting conditions attached to them. So there is literally an entire 3-page doc about how to interpret this user identity field. And if you care a lot about AWS security, you should go read it. It's made several things more clear to me, but it's much too long to talk about right now. CloudTrail docs are pretty confusing and not that straightforward, but in real talk, I understand that I'm spending a bunch of time harping on a team that is a team of make you real humans, and I want AWS people, if they see this, to know that I don't actually just all hate them, and I have a tremendous amount of respect for what they do. I just think they could do slightly better. So we've talked about CloudTrail, which is the source of where we're going to get the security data from Amazon. Now we're going to talk a little bit about EQL, which is how we're going to query that data and construct rules. So EQL is a query language for JSON-like data. And what this really means is that EQL runs over data that you don't know the schema of in advance. And as we talked about, there's all these fields and events that get defined per event type and are not predefined. So this is what EQL really starts to shine through and show its power of. It's primarily used for security rules and analytics. We use it in Endgame product, for instance, but it's totally open source and you can go use it yourself on any JSON-like data you want. That's actually how I'm using it. I don't have any secret inside package or anything. It's got a bunch of really useful features that you may not expect. One of which I like to explicitly call out is actually sequences. We'll maybe see an example later, depending on how fast I go. But sequences allow you to do this cool thing that if you have a collection of events in order, you can actually go and say, hey, I'm looking for a series of events that happened. Maybe someone turning off some security controls, for instance, and then doing something against that object that the security controls would have prevented. Each of those in isolation may not be suspicious, but if one user account does them immediately back to back in 10 minutes, oh boy, someone should probably go look at that. I don't know if someone had the reason to do that, but it's at least worth looking into. So really quick, let's kind of talk about an equal rule as they look for like normal security analytics. This is a process rule where we have a subtype create, and you can see this is basically just a rule looking for someone running reg.exe and then looking for several command line arguments on there. This is about as basic as it comes. It's pretty easy to write, and it conveys kind of the structure of the language. Equal has all the things you would expect a normal query language to have, right? It has equals, ands, ors, and all that. It has recursive array searches and that sort of stuff, which we'll kind of get to later. But it's very easy. You can pick this up in 5 minutes. Nothing is very complicated about it. There's a very nice document online that one of my coworkers maintains that has all of the kind of the overview of this language. So we're going to now quickly break for a short demo because I fear the demo gods a bunch and didn't want to tempt them. So really quick, let's kind of talk before we kind of launch into this. Equal has basically two parts to how it works. Part one is every time a CloudTrail log file gets dumped in this bucket that we talked about earlier, Equal gets an event from S3 and launches a Lambda where it goes ahead and pulls down all of the files that it may want to look at recently. So we search back about 60 minutes to 2 hours. The reason we do this is for those sequences I mentioned. So the amount of time you want to look back is how long you can construct a sequence, right? If you're not looking for 3 hours back, if you have a sequence that happens, 3 hours back and then in an hour, it won't pick it up. The other part is this web interface. I think user interface is pretty important in most security products. It should be nice to use. It should be simple to use. You should understand what you're looking at very clearly. Varna is intentionally pretty minimalist, and that's because I have to stare at it a couple times a day, and I don't want to have to click 17,000 buttons every time I try and do something. So what we're looking at here is this is the web interface for Varna, and this is designed to be deployed however you want to deploy it. I'm not solving your auth problem because there are 47,000 ways enterprises auth apps, as I've discovered. And what we're looking at here is this is the first kind of screen of Varna that we look at, which is this is the list of rules. All of these are getting released with Varna as well. And I consider most of these to be very suspicious, right? If these are happening, if someone is making new users in your account, if someone is logging in as root, root is an IAM user that you basically can't get rid of any of the permissions from, and so is very dangerous in AWS permissions. It's exactly like it works on Linux. Those are all kind of suspicious things, and you should know about them. So we think this is a pretty good set of core checks that'll get you some of this stuff. And you can scroll through and you can copy and paste any of these rules, and we'll see why that's kind of important in a second. This is the list of alerts. So this is a list of every recent alert that's fired. And you can see we're looking right now through an alert. And this is actually triggered off of the authorized security group rule I showed you. And we'll talk about that rule a bit later, but it basically tells you when someone tries to make your security group open to the world. And so what you can see is you can scroll through and look at all these alerts like you would normally. These are the full details of the CloudTrail alerts, except they also include some Varna-specific metadata fields you may find interesting or useful. You can also click to see only unacknowledged alerts. So in Varna, there is kind of this system of acknowledging alerts, which we'll see. So you'll see we just marked that alert as acknowledged. Varna is a monitoring tool. It's a visibility tool. And so inevitably there are going to be false positives, right? Someone is going to have to log in. A couple months ago, I had to log in with a root account to fix an IAM permissions issue that I accidentally screwed up, right? That's a normal thing, right? And you will, as administrators or as security personnel, always probably trip the same rules that you set up to detect anomalous action. So the acknowledge system is more so a way when rules get either emailed to you alerts get either emailed or Slacked to you. They'll also include a link to acknowledge them. And basically the way this operates for us, and I can't tell you how to run your team, is that we have a Slack channel that all of our people sit in. And when one of these alerts pops up, we can kind of quickly go around the room and say hey, was this any of us? If so, click the acknowledge button. If not, oopsies, that's bad. We should go figure out. In practice, this is the minimal flow I find to successfully kind of curate these alerts. And Varna actually also includes a cron job, so it'll remind you once a morning or whenever you set it, because you can control how often it does, to like, hey, you have 15 unacknowledged alerts, and it'll take you to this unacknowledged alert page so that you can look through them and like acknowledge them. Varna also has this feature that it lets you run past searches in a way with full context. So you can go back as far as you have CloudTrail history to go do searches. So right now, we're actually going to do a quick search, and we're going to look for a console login that I did earlier this week when I was developing things. And you'll see this is actually going to take a second. My mouse is actually going to spin for a second because this is actually pulling all the files off of S3 and then decompressing them and sorting them and getting them all ready for you. This is why there's kind of a search limit to Varna and how far back you can go. In practice, the search limit is how much money you're willing to pay Amazon for Lambda runtime. In practice, we figured out it's about 3 hours because humans really don't like to wait for their queries to go longer than that. I have some interesting ideas about how to make Varna do like multiple day searches and stuff, but that's kind of out of scope. And so you'll see I pulled up this alert. I'm not going to click on it because that's actually our real company's data, and I can't edit the database to make that alert not say private things about us. But it's the same thing as you would expect from the other alerts page. Now, we're actually going to do a kind of weird alert here. One of the things that's kind of cool about EQL that I think doesn't get talked about enough or isn't talked about in security tooling enough is how visibility and exploring your data works. So right here, one of the first questions that anyone asks about CloudTrail when they get access to it is like, what is happening? There are thousands to, tens of thousands of CloudTrail events for every 5 or 10 minute period that you're looking at. It is just an unbelievable deluge of data. And so we're going to show you a query right now that EQL allows us to run and that Varna handles for us intelligently, where we're going to say, hey, I want every event that has an event name, which is all of them, and I want to know a count of what event name that was. So what you're going to see here is we're going to wait again because this is all being done real time and I didn't edit this video, which I probably should have, but seemed just ingenuous. But what you're going to see here is that Varna is going to pull up all of these results for us. And so you can see in that 30-minute period we were querying, 2 people asked to create a log stream. 1 person asked to discover an endpoint. 6 times we called a describe container instance, right? All of these are fairly normal things, but they're very useful for starting to get kind of a picture of what is happening in your account, right? We know why all of these things are happening in our account, right? We've gone through and we've done the checks and said like, okay, when we monitor this thing, it causes these alerts in the back end. It's very useful to kind of take a large approach to this, right? If something's happening 2,000 times in your account, you should probably know why that's happening to some extent. All right, I think this is the end of the video. Yep. All right, so let's talk a little bit about the costs of Varna. So Varna is kind of hard to cost because AWS, I swear to God, makes this purposely hard to tell how much anything costs. And there's about a half a dozen nickel and dime charges. But as best as I can tell, we've run it in prod. I've done some like rough benchmarking. I've installed it in another account, just like a naked account to run. It can run as low as $5 a month, or in the configuration we run it in, and that I recommend you run it in, it's about $15. It's a little bit less than that. It's one DynamoDB table and an index, and it's some Lambda and S3. And that's actually how it all runs. And I would like to point out, because one of my coworkers made me say this, it's serverless. And so really you're paying Amazon to use their servers. But there isn't any maintenance you have to do about a box or anything, right? You don't have to patch an operating system. The whole idea is that this is really easy to kind of attach into your AWS account and have it run all the time for very low cost with very low friction. And it's an easy tool to use. Varna makes some unusual best practice choices, and that's because I come from a very software-oriented team. We write a lot of software, but it's also because I think some things about security that I'd like to hopefully convey with you when you use this tool. I think version control for a lot of security settings is very important, because oftentimes knowing when rules or settings were modified for security tools is very important, because it changes when you can observe and what you can see. So we keep this all in Git. Including our rules. We keep our rules in a subdirectory, a sub-repo that we install in. And then, ideally you want to update this via CI/CD. So you have a GitHub account or a GitLab or whatever Git host of choice you use. And you commit basically all of that into here. And then when your CI/CD notices changes, it picks them up, bundles them up, and deploys them out to prod for you. This allows you to always have kind of a time in record of like, hey, John went in and modified the no MFA check to exclude this user because they can't use MFA. I don't know why that is, but hypothetical. And it allows you to also write really good commit messages and have very good documentation. Part of Git or any like CI/CD kind of version control paradigm you're using is that you can have a modified log here. And so you can go back and say like, hey, we last modified this rule for this reason, and that's why it happened. One other thing I just like didn't kind of fit naturally, Varna is designed to have a pretty low level of alerts, right? It emails people and Slacks people when it sees things, and people hate alerts, like viscerally. So Varna is pretty designed around the idea that you should have maybe less than one alert a day firing. We guard against things that we think attackers are going to do as like course when they get into an account that look very suspicious to defenders. But we don't try and alert on like things that would spam tens or dozens of, per day, because people don't want to acknowledge that many alerts. Our production Varna instance, I think, probably spits out maybe 5 alerts a month or something. It's pretty low traffic, and that's the way we kind of like it. It's not supposed to be a thing that we have to check every day. And congrats, I didn't touch my laptop long enough. And so you need to basically tune it to have pretty low alert fatigue. So let's talk about some of those EQL analytics that we're dropping with Varna, because I like talking about CloudTrail stuff. So here's one, and this is the simplest rule you could possibly make. And if I could convince you to do one thing in your AWS account today, it's probably that you should run this rule in Varna. Root accounts in AWS are a really bad security paradigm. If you're depending on them, it's very hard to limit their access. It's very hard to like track or make them observable. And so we just alert on everybody who logs in as root. It should never happen. All of our people have, SAML or other means of getting into the account with better secure credentials. And so we just basically bury our root things in a box under a bed. So here is the bucket logging check, which is actually wrong. There's supposed to be a not in front of that request parameters. That's what I get for copying this late at night. And basically what this rule does is it's very simple. It says, hey, if we're putting a bucket logging configuration together, we should make sure that it's enabled. We never want certain of our buckets to have logging that it gets turned off. And so this lets us know if somebody goes into S3, either the console or the API, and turns off the bucket logging, that just pops us right away. Like I was saying, this is sort of an example of how you can see how request parameters has weird key structure. The way you tell this is that there's a bucket logging status and then logging enabled. There is no consistency to this. You can have calls that touch the same sort of base primitive in AWS, and they will use different keys. I'm sorry. I wish I could help you there. Here's probably a good rule to demonstrate some of the flexibility of Varna and EQL and show you how you can kind of dig into these very complicated JSON structures. So security group updates are actually kind of a really gnarly mess. And basically how they work is there's an array of IP permissions that get shipped to you. And then inside that array of IP permissions, there's also an array of IP ranges. So we have to search through this like complicated multi-level structure to construct this rule, right? It still only took me about 10 minutes. And basically what this rule does is it says, hey, every time there's an IP permission change for a security group, we want to check if the protocol is TCP, if the port is 22, and if one of the ranges that's changing is the whole world. And basically this is because people really like to pop into AWS accounts, and they really like to enable literally everything in the world on for security groups so that they can get to them from other places. Warning, Varna is beta. We use this in production. You should use your head and like actually look at it and like understand what it's doing before you do so. There will be bugs. A bunch of this code actually changed within the last 2 weeks because I was releasing it and I had code shame, and so I fixed it up for you all. But if there are bugs, you can DM me, or there's a GitHub issues tracker, and we'll get them fixed out. Look at the rules. Make sure they work for you. If you have work that you want to see in Varna that you really want, we're pretty happy. It's pretty stable and self-contained for us. But I'd love to talk to people and know how they want to extend it.